All right, so test is 11:1 to 11:3, and this is Friday. So you guys won't have it first on Friday. You'll have it after lunch because the order's different. You can use a scientific calculator, not a function one. So let me show you what those look like. So I think it's these three types of calculators not okay because they have summation on them. So you literally have a button that will do your summation for you. So these are not okay. If you don't have a scientific calculator, you can use the lockdown scientific calculator. So you can use the one that's in lockdown, but obviously if you're comfortable with a scientific one, those are easier because you're already comfortable with the one you're going to use. The regular TI one is fine. The one that's colored, like sometimes there's blue or pink, those ones are fine. But if it has a summation button on it, you cannot use it. So usually it will say it's a function calculator, but these three are big time no-nos, okay? You survived. So other than that, if you want me to, like that one's totally fine. That one's good. If you hold that up. That one is fine. Anybody else have a scientific one with them? So my advice would be what's yours look like? Same one, okay. My advice would be if you have one at home, start bringing it with you tomorrow. And I'll tell you if it's good or not. If you don't, then again, you can use the lockdown one. We'll practice that Wednesday. Like I'll let you get in there so that you know what it looks like so that's easy, okay? But basically it looks like your iPhone calculator when it's turned widthwise. That's what it looks like. Pretty similar to that. So like this guy, that one. Okay, that is what you will get on lockdown. It's pretty similar to that. Okay, and you can use it the whole time. Yeah. No, you cannot use a graphing one and you cannot use a function one. Yeah. Right now the test is 15 questions. I don't know if it will get tweaked, but right now it's 15 questions. And it's going to kind of go in random order. So that's part of the really important part about paying attention to instructions. Because you've got just your general sequence and series, and then we went arithmetic, and then we went geometric, okay? So a couple of things on notation. Obviously, if it says to find the sum of something, and it's just a series of numbers, you're going to have to figure out if it's geometric or arithmetic before you find the sum of it. Does that make sense? Okay. So if it said something like find the sum of the first, 100 terms, and it starts with 2, 5, 8, 11. So the first thing you have to do is what? What did I just say? You have to figure out what kind of series it is, right? Sequence. So is this arithmetic or is this geometric? It's geometric. You're adding the same thing each time, right? If I take 5 divided by 2 and 8 divided by 5, it's not equal. But if I do 5 minus 2 and 8 minus 5 and 11 minus 8, it's 3.
Wait, isn't geometric?
Did I say geometric? It's arithmetic.
So arithmetic is
Adding or subtracting the same thing. Yes, it is arithmetic, okay? And D is a positive 3. How do I find the sum of an arithmetic sequence?
N2 and then first and
Good. N over 2 times first plus last. So what I already know is N, right? Because that's 100. I know the first term is 2. What I don't have yet is the last term. How do I find the last term? You got to find the formula, and then you got to find A100. So it's not going to tell you that, right? It could say find AN, and that means find the formula, and then find the sum. But it also just might say find the sum, and you have to know that you have to find the last term. So I'm going to first find AN, which is A1 plus D times N minus 1. So AN is 2 plus 3 times N minus 1. Now, if I'm giving this answer as part of the answer, like if it literally says find AN and then find the sum, then I have to distribute this and combine my like terms. If it doesn't say that, I don't need to distribute it. I can actually find A100 from here. If it's not asking for AN as part of my answer. Either way, I now need to find A100 because that would be the last term if there's 100 terms. So A100 is -1 plus 3 times 100, -1 plus 300, which is 299. Yeah. No. So now you get this, right? And then obviously this is why you're given your calculator. Well, not really this one. I felt like we could handle this one. But you will get given your calculator so that it makes these a little bit easier. So then I get 50 times 301, which is 15,050. With me so far? Okay, so now what if it says the same thing? Find the sum. The first, we'll go easier. 20 terms. Give me a number to start with. 3. Let's do 3/4, 3/16, 3/64. Is this geometric? Yes, right? If I take 3/4 and divide it by 3, which is multiplying by a third, I get 1/4. If I take 3/16 and divide it by 3 or multiply by a third, wait, what did I just do? I didn't do it geometric, did I? Yeah, multiply by a fourth, multiply by a fourth. 3/16. Oh, 3/4. Thank you. Divided by 3/4 would be 4/3. And then 1/4 again. Okay? So this time I know it's geometric. So remember, within geometric, there's finite and there's infinite. Is this finite or is this infinite? This is finite because it says the first 20 terms, right? So sum of finite, geometric, is A1 times 1 minus R to the n over 1 minus R. A1 is 3. 1 minus R is 1/4 to the n, which is 20, over 1 minus 1/4. So now I would do 4. So this is where you got to be careful with your calculator because I don't want that to be a decimal. Oh, and I picked 20. That was way too big. Here, let's do 10 terms. 10, I think even that's too big. Yeah, that'll work. Okay, it's big, but it'll work. All right, so 3, 1 minus 4 to the 10th is 104,857.6. Mm-hmm.
Could you just do 4 to the 20th and just put what that is in the bottom?
Yeah, it's just like when I did it, I got e to the 12th, which means there's 12 decimal points. Like you'd have to move it over. You won't have something that big if it's geometric. So then this goes 1 minus 1/4. Then you have to find the least common denominator. So this would be 104,857.6 over the same number, 104,857.6. Subtract 1 from that. And I get 104,857.5 over 104,857.6. I promise you the number's not that big. They do get a little bit big, but not like that. And then this is 4/4 minus 1/4, which is 3/4. From here, I keep change flip. And then the 104,857.6 divided. 4 goes into that big number, 262,144 times. 3 goes into 104,857.5 divided by 3. 3,49525. And then this is gone. So I have 3 times 3,4,9,5,2,5 over 2,6,1,4,4. 2,6,2,1,4,4. And then 2,6,2,1,4,4 divided by 3. Oops. Doesn't go in evenly. So I'm going to multiply this out. 3,4,9,5,2,5 times 3. And I get 1,0,4,8,5,7,5 over 2,6,2,1,4,4. And you will keep your answer like that. Okay. Again, the numbers are not that big. But you want to make sure that you keep it that way. And be careful how you use your calculator, because if you put that in decimal form, it's wrong. Yeah.
From the beginning, couldn't you just divide both fractions by 3, and then it would be just easier to...
Which?
Like the things in the light purple. The light purple.
Here.
3. No, to the right.
Here.
Yeah, all that. Can't you just divide it by 3?
Well, but it doesn't go in evenly. It didn't go in evenly. If you could. Do you mean the denominator?
If you like the 3 on the outside. If
You can't divide by 3 because it's not an equation, right? Because then at the end you have to multiply by 3 again.
Okay.
So you can only do that if 3 goes into that number. Yeah. You're welcome. Okay, so now what changes if I say find the sum of the sequence, and I give you the same sequence, 3/4, 3/16, 3/64, dot, dot, dot. Now what is it? Infinite. I didn't stop it, right? So in order for you to be able to find the sum for an infinite series, it has to have an r that's a fraction, right? Because we already know r is 1/4. I know this can be done, okay? But that has to be a fraction in between 0 and 1, the absolute value of it, in between 0 and 1. So it can't be improper. It can be positive or it can be negative, but it can't be bigger than 1, okay? So now I would, that one is a1 over 1 minus r. So this would be 3 over 1 minus 1/4. This becomes 4/4, 3 over 3/4. Keep, change, flip, and you get 4. So if there is no termination, if it doesn't say the certain number of terms, then it's infinite. But in order for it to be infinite, to find the sum, it has to be a fraction. So if this was, let's say this was 5, 10, 20, 40. This is geometric. You're multiplying by 2 every time, right? But you cannot find the sum of this infinite. Cannot be found. Questions on any of that stuff so far? Yeah.
Is that the only way it would be cannot be found?
Yeah. Well, I mean, it has to be geometric, and like the only infinite that you can find is geometric with an r that's a fraction. So like if this arithmetic, you couldn't find it either if it didn't tell you to cut it at 100 terms. It's got to have a finite. There's no infinite arithmetic. So the only time you can find infinite is if it's geometric and the r is a fraction. Yep. Good? Okay. So the other thing you're going to see is the notation like this. What does that mean? So this means the sum of the first 100 terms. Okay? So this would be the same as what we just, you could get given a sequence, or you could get given like an equals, 2 minus 3n. And it could say find S100. And this means find the sum of the first 100 terms. So then I have to look at an. Is that geometric or is that arithmetic? And how do you know the difference? It's arithmetic. How do you know the difference? Good. Geometric has a power. So if it said 2 times 3 to the n, this would be geometric. If it's just multiplication with addition or subtraction, or just multiplication, then it's arithmetic. So now I'm finding the first 100 terms of an arithmetic sequence, which means I'm using n over 2 times first plus last. What's n? 100. How do I find the first and how do I find the last? Good. First, I plug in 1. So this would be 2 minus 3 times 1. 2 minus 3, which is negative 1. Last, I plug in 100. 2 minus 3 times 100. 2 minus 300, which is negative 298. And I get 50 times negative 299. 2. Which one? The last, right? The last is negative 298, but then you add them because they're negative. So 14,950, and it's negative. And a sum can totally be negative. Like if you're adding a bunch of negative numbers together, obviously you're going to get a negative sum. Yeah.
Can you go back to the one?
The other notation that you haven't seen yet is factorial notation. So this, like, hopefully you've seen it before now, but if I have something like this, the exclamation mark, this means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, okay? That's what that means. 8, 7, 6, 5, 4, 3, 2, 1, okay? So you would multiply all those out. This actually comes in to play a lot of times with probability. But you won't see it like that. You would see it like, let's say it says 7 factorial over 2 factorial. So what you could do with this is go 7, 6, 5, 4, 3, 2, 1. And then in the bottom, 2 times 1. And then you could multiply out the top, divide by 2, or you could cancel and then multiply what's left. But I would say even easier than that is instead of going all the way to the end, you want to take the bigger factorial and break it down until you hit the smaller one. So this one doesn't save us much, but if it was like a 3 factorial, it would save you more. So I would do 7 times 6 times 5 times 4 times 3 times 2 factorial. Put it over 2 factorial. These cancel, and I still multiply the rest out. So think about like if it said 35 factorial over 32 factorial. I don't want to write out 35 to 1, and I don't want to write out 32 to 1. So I would do 35, 34, 33, 32 factorial over 32 factorial. Cancel these out, and then you only have to do 35 times 34 times 33.
This isn't going to be on a test, though.
Mm-hmm. You're going to see factorial on your test. Yep. Yeah.
Wait, how'd you get from 8 to 7 over 2?
No. It's a different question.
Oh.
Yeah, different question. So then you'll also see these with expressions. Like if it says n plus 3 factorial over n plus 1 factorial. Which of those is bigger? The n plus 3. So I'm going to take the n plus 3 and I'm going to subtract 1 from it until I hit the 1 in the bottom. So it would be n plus 3 times, subtract 1 from there, n plus 2 times n plus 1 factorial over n plus 1 factorial. And then these cancel, and I'd get n plus 3 times n plus 2. And you can either leave it like that, or you could FOIL that out, n squared plus 5n plus 6.
Are we going to have to, like,
I would take either answer. Yep. Questions so far? Yeah. Record. So this is arithmetic because I only have addition and multiplication, right? How many terms are there if it goes from 0 to 400? 401. Remember, if it's not 1, it's top minus bottom plus 1. So it's 401 terms over 2. For the first, we're going to take and plug in 0. So I get 3 times 0 plus 2, which is 2. That's my first term. And for the last, I'm going to take and plug in 400. 3 times 400 plus 2, 1200 plus 2, 1202. So then I get 401 over 2 times 1204. $241,402.
Would it be some that are like arithmetic like that?
Yeah.
I mean, sorry, geometric.
Geometric that are that high? No, just because you're, so it would be still something I wouldn't want to plug in. It could be like 8, maybe. I don't want to plug in 0, 1, 2, 3, 4, 5, 6, 7, 8, and then add them all together, especially if it's like exponents. So you'll be able to use it. But it like, so that would be it could be 0, 2, maybe like 1/3 to the I, and maybe this is 5 or 6 or 7 or 8, something like that. So you could do it by plugging in 0, then 1, then 2, then 3, then 4, then 5, and adding them all together. But you're going to get a least common denominator. You're going to have to add them all together. Or you do the A1 times 1 minus r to the n over 1 minus r.
So since we know those formulas now, we can just use them.
Yeah. Yep. So the A1, I'd have to plug in 0. 1/3 to the 0 would be 1. A1 is 2. 1 minus. The r is 1/3. It would be to the 6th power because 5 minus 0 plus 1. And then 1 minus 1/3. So the exponents there are not going to be huge. Maybe like 7, 8. I think 8 is the highest. Maybe you would see something like that. But this is where you got to be careful with your calculator. Like, don't use it to get a decimal. Do 3 to the 6th and keep it as a fraction.
Will it always be 0?
No. That could change to 3 if you wanted it to.
And then is r always
The thing being raised to the power. Yeah.
So if we go geometrical and arithmetic, if we do all of them plus the bottom minus plus 1.
Top minus bottom plus 1. Yep.
So for this one, if it was 5 and 3, it would be 3.
Yep.
Wait, so when we started and like you broke up, like for the first one we did where it was like 3i plus 2.
Yeah.
And, like, broke it up and
You can do that, but I think it's probably, now you know arithmetic.
the same thing.
Yeah. As would plugging in the bottom number up to the top. All of it gives you the same.
So you could just use the
I think arithmetic at this point would be easier. So anything that's got just addition, just multiplication, or addition and multiplication together is arithmetic. Anything raised to a power is geometric. Yep.
Is the A1 always in front of
No, because look, right now, if I change that to 3, I'd have to plug in 3 to get the first term. So this would be 1 over 27. So A1 is 2 over 27. So A1 is by plugging in the bottom number. You're welcome. All right, we're going to get into the class case. So it says find the specified term of the geometric sequence. It wants you to find A3. So I have A1 and I have A4, right? If I want to find this would be A1 r to the n minus 1. That's my formula to find any term in the sequence. I know A1 is 20, but you don't know r yet. So if you have a jump, like you don't have consecutive terms, remember, put the bigger base on the left. So A4 would go on the left. The smaller base goes on the right. And then r is raised to the difference, 4 minus 1, which is 3. Then plug in what you have. So A4 is 135 over 16. A1 is 20, r to the third. And then solve for r. So divide both sides by 20 or multiply by 1/20 here. Oh, they're both divisible by 5. This would be 27. This would be 4. And you'd end up with 27 over 64. So then when you cube root both sides, the cube root of 27 is 3, and the cube root of 64 is 4. Now I know R. So I can find any term. If it asks you for the third term, it's 20 times 3/4 and then 3 minus 1. So 20 times 3/4 to the second, 20 times 9/16. These are both divisible by 4, and you'd get 45/4. Okay, this is 5. So first you're finding a sub n, right? So a n would be 8 times 1/2 to the n minus 1. And then it wants you to find the 10th term. So a10 is 8, 1/2 to the 10 minus 1. 8, 1/2 to the 9th. 2 to the 9th is 1 over 5/12. And then 5/12 divided by 8 is 64. So you just put it as a whole number. Maybe you just forgot the 1 over. Yeah. All right, then this is 6. So I wonder if you did the same thing. So 6 times negative 1/3 to the n minus 1 is the equation. And then it wants you to find the 10th term again. So 6, negative 1/3 to the 10 minus 1 would be to the 9th. 3 to the 9th. Because it's odd, it's going to say negative. 1 over 19,683. And then 6 does not go evenly into that. Are they both divisible by 3, though? 19,683 divided by 3. Yep. So they're both divisible by 3. This would be 2. And this is 6,561. So it's negative 2 over 6,561.